In electrical installations involving multiple 230-volt heaters, where a neutral conductor is required, it is essential that each individual circuit has its own dedicated neutral. The reason for this lies in a fundamental principle of how electrical circuits operate. The neutral conductor serves as the return pathway for the alternating current, allowing it to flow back to the source, typically the transformer or service panel. This completes the circuit and enables the appliance, in this case the 230-volt heater, to function. If multiple 230-volt heater circuits were to share a single neutral conductor, it could lead to several problems, including overloading the neutral, creating voltage imbalances, and potentially causing equipment damage or even fire hazards. Firstly, consider the aspect of neutral conductor overloading. In a balanced three-phase system, the neutral conductor ideally carries little to no current. However, in single-phase circuits like those typically used for 230-volt heaters, the neutral conductor carries the imbalanced current between the hot conductors. If multiple 230-volt heater circuits share a single neutral, the current from each circuit will add together in the neutral conductor. This can result in a current flow exceeding the neutral conductor's ampacity, which is its current carrying capacity. Overloading a conductor causes it to overheat, potentially melting the insulation and creating a fire hazard. Secondly, the sharing of a single neutral conductor among multiple 230-volt heater circuits can create voltage imbalances. Voltage imbalance occurs when the voltage between each hot conductor and the neutral conductor is not equal. This can happen if the loads on each circuit are different or if the neutral conductor has excessive impedance. When voltage imbalances are present, it can cause equipment to operate inefficiently, overheat, and potentially fail prematurely. In the case of 230-volt heaters, voltage imbalances could lead to uneven heating, reduced lifespan, and increased energy consumption. Thirdly, the lack of dedicated neutrals can lead to increased harmonic currents. Harmonic currents are currents with frequencies that are multiples of the fundamental frequency, typically 60 Hz. Nonlinear loads, such as electronic devices and some types of heaters, can generate harmonic currents. These harmonic currents can flow through the neutral conductor and, if shared among multiple circuits, can create excessive neutral current, exacerbating the overloading issue. The National Electrical Code, or NEC, provides guidelines for the installation of electrical systems, including requirements for neutral conductors. It is important to consult the NEC and any applicable local codes to ensure that the installation meets all safety requirements. The NEC typically requires that each circuit have its own dedicated neutral conductor, especially in situations where multiple circuits are serving similar loads. When installing 230-volt heaters that require a neutral connection, it is best practice to run a dedicated neutral conductor for each circuit back to the electrical panel. This ensures that the neutral conductor is properly sized to handle the load of each circuit and that voltage imbalances and harmonic currents are minimized. In addition to running a dedicated neutral conductor, it is also important to properly size the conductors for each circuit. The conductor size should be based on the ampacity of the circuit and the length of the run. The NEC provides tables that specify the minimum conductor size for various ampacities and conductor types. Furthermore, ensure that all electrical connections are made properly and are tight. Loose connections can create resistance, which generates heat and can lead to equipment failure or fire hazards. Use appropriate connectors and tools to make secure connections. Finally, after completing the installation, it is advisable to have a qualified electrician inspect the work to ensure that it meets all applicable codes and safety standards. An electrician can identify any potential problems and ensure that the system is operating safely and efficiently. In summary, when installing multiple 230-volt heaters that require a neutral connection, it is essential to run a dedicated neutral conductor for each circuit back to the electrical panel. This helps to prevent overloading the neutral, minimizing voltage imbalances, and ensuring the safe and efficient operation of the heaters. Always consult the NEC and local codes and seek the advice of a qualified electrician if you have any questions or concerns. Consider the practical implications of sharing a neutral. Imagine 3 230-volt heaters, each drawing 10 amps. If they shared a single neutral, that neutral would potentially carry 30 amps. If the neutral wire were only rated for 20 amps, it would overheat. This is a significant fire risk. Consider also that even if the neutral wire were rated for 30 amps, the constant high current could cause premature degradation of the wire and its insulation. To further illustrate, let's examine a few possible scenarios. Scenario 1 involves three 230-volt heaters, each on a separate 20-amp circuit, all sharing a single neutral. In this scenario, the neutral would be carrying the combined current of all three heaters. This would likely overload the neutral and cause it to overheat. This is a dangerous situation that could lead to a fire. Scenario 2 involves three 230-volt heaters, each on a separate 20-amp circuit, each with its own dedicated neutral. In this scenario, each neutral would only be carrying the current of its respective heater. This would prevent overloading the neutral and ensure that the system operates safely. Scenario 3 involves three 230-volt heaters, each on a separate 20-amp circuit, with two of the heaters sharing a neutral and the third heater having its own dedicated neutral. In this scenario, the shared neutral would be carrying the combined current of two heaters. This would likely overload the shared neutral and cause it to overheat. This is a dangerous situation that could lead to a fire. It is also important to consider the impact of harmonic currents on the neutral conductor. Harmonic currents are currents with frequencies that are multiples of the fundamental frequency, which is typically 60 Hz. These currents can be generated by nonlinear loads, such as electronic devices and some types of heaters. Harmonic currents can add to the current flowing through the neutral conductor, which can further overload the neutral and cause it to overheat. To mitigate the risk of harmonic currents, it is important to use properly rated neutral conductors and to install harmonic filters if necessary. In addition to the electrical safety concerns, sharing a neutral conductor can also lead to operational problems. For example, if one of the heaters were to fail, it could cause a voltage imbalance in the other heaters. This could lead to uneven heating and reduced lifespan. In conclusion, when installing multiple 230-volt heaters that require a neutral connection, it is essential to run a dedicated neutral conductor for each circuit back to the electrical panel. This helps to prevent overloading the neutral, minimizing voltage imbalances, and ensuring the safe and efficient operation of the heaters. Always consult the NEC and local codes and seek the advice of a qualified electrician if you have any questions or concerns. Moreover, understanding the concept of balanced and unbalanced loads is crucial when discussing neutral conductors. In a perfectly balanced three-phase system, the currents in each of the three hot conductors are equal in magnitude and 120 degrees apart in phase. This results in a neutral current that is ideally zero. However, in real-world scenarios, loads are rarely perfectly balanced. This means that the currents in the hot conductors are not equal, and a neutral current will flow. The amount of neutral current depends on the degree of unbalance. In single-phase circuits, the neutral conductor always carries the return current, which is equal to the current in the hot conductor. Therefore, in the case of 230-volt heaters, each heater constitutes a single-phase load, and its neutral conductor must be sized to carry the full load current. Failing to provide a dedicated neutral for each heater can lead to a situation where the shared neutral conductor is undersized for the total load current, resulting in overheating and potential fire hazards. It's also important to consider the voltage drop in the neutral conductor. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to operate inefficiently and can even damage it. The voltage drop in the neutral conductor can be particularly problematic because it can affect the voltage supplied to all of the circuits that share the neutral. To minimize voltage drop, it is important to use conductors that are properly sized for the load current and the length of the run. The NEC provides guidelines for calculating voltage drop and for selecting conductors that will keep voltage drop within acceptable limits. When running multiple circuits in the same conduit or cable, it is important to consider the deterring factors that are specified in the NEC. Deterring factors are used to reduce the ampacity of conductors when multiple conductors are bundled together. This is because the heat generated by the conductors can raise the temperature of the insulation, which can reduce its ability to withstand current. The NEC provides tables that specify the dating factors for various numbers of conductors and conduit types. When installing 230-volt heaters, it is important to use the correct type of wiring for the application. The NEC specifies the types of wiring that are permitted for various applications. For example, non-metallic sheath cable, or NM cable, is commonly used for residential wiring. However, NM cable is not permitted in some locations, such as damp or wet locations. In these locations, it is necessary to use a different type of wiring, such as underground feeder, or UF cable or conduit. It is also important to use the correct size of conduit for the wiring. The NEC specifies the minimum size of conduit that is permitted for various numbers and sizes of conductors. Using the wrong size of conduit can make it difficult to pull the wires through the conduit and can also damage the wires. When making electrical connections, it is important to use the correct type of connectors. The NEC specifies the types of connectors that are permitted for various applications. For example, wire connectors or wire nuts are commonly used to connect wires together. However, wire nuts are not permitted in some locations, such as damp or wet locations. In these locations, it is necessary to use a different type of connector, such as a crimp connector. It is also important to make sure that the connectors are properly tightened. Loose connections can cause resistance, which can generate heat and can lead to equipment failure or fire hazards. Before working on any electrical circuit, it is important to turn off the power at the circuit breaker. This will help to prevent electric shock. It is also important to use a voltage tester to make sure that the circuit is de-energized before working on it. Even after the power has been turned off, there may still be a residual voltage in the circuit. This voltage can be dangerous, so it is important to use a voltage tester to make sure that the circuit is de-energized before working on it. When working on electrical circuits, it is important to wear appropriate personal protective equipment, or PPE. PPE can help to protect you from electric shock, burns, and other injuries. PPE includes items such as rubber gloves, safety glasses, and insulated tools. Rubber gloves can help to protect you from electric shock. Safety glasses can help to protect your eyes from flying debris. Insulated tools can help to protect you from electric shock if you accidentally touch a live wire. In summary, the electrical installation of 230-volt heaters requires careful attention to detail and adherence to the NEC and local codes. Providing dedicated neutral conductors for each circuit is crucial for safety and proper operation. Always consult with a qualified electrician if you have any questions or concerns. The consequences of improper wiring can be severe, so it's always best to err on the side of caution. The proper operation of electrical systems relies on the correct application of fundamental principles. These principles include Ohm's law, which relates voltage, current, and resistance, and Kirchhoff's laws, which govern the flow of current and voltage in circuits. Understanding these principles is essential for troubleshooting electrical problems and for designing safe and efficient electrical systems. Furthermore, when considering the installation of 230-volt heaters, it is imperative to account for the potential for ground faults. A ground fault occurs when a live conductor comes into contact with a grounded surface, such as a metal enclosure or a water pipe. Ground faults can create a dangerous shock hazard. To protect against ground faults, the NEC requires the use of ground fault circuit interrupters, or GFCIs, in certain locations. GFCIs are designed to detect ground faults and to quickly interrupt the circuit, preventing electric shock. While GFCIs are not typically required for 230-volt heater circuits, it is still a good idea to consider using them, especially if the heaters are located in damp or wet locations. In addition to GFCIs, it is also important to ensure that the electrical system is properly grounded. Grounding provides a lower resistance path for fault current to flow back to the source, which helps to trip the circuit breaker and de-energize the circuit. Proper grounding is essential for safety and is required by the NEC. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the grounding electrode to the electrical panel. The grounding conductor must be properly sized and installed to ensure that it can effectively carry fault current. The size of the grounding conductor is based on the size of the service entrance conductors. In addition to the grounding electrode and the grounding conductor, it is also important to bond all metal enclosures and equipment together. Bonding ensures that all metal parts are at the same electrical potential, which helps to prevent electric shock. Bonding is typically accomplished by using bonding jumpers, which are short lengths of wire that connect metal parts together. The bonding jumpers must be properly sized and installed to ensure that they can effectively carry fault current. When installing 230-volt heaters, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide detailed information on how to install the heater safely and correctly. The instructions will also specify the type of wiring and connectors that should be used. It is important to use the correct type of wiring and connectors to ensure that the heater operates safely and efficiently. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to install the heater. An electrician will have the knowledge and experience to install the heater safely and correctly.